Hello everybody, this is Cameron Snow with Danomics.com. So in our previous videos in our Danomics Basics series, we've gone through and we've calculated several of our key rock properties like our clay volume, porosity, water saturation, and permeability. We've calibrated those to core here, so we've got a nice match. And now what we want to do is we want to go through and set up some cutoffs so we can better understand which zones have potential to flow oil or water, and then we're going to evaluate the volumetrics. All right, so let's get started. So, like I said, we've already calculated those properties. So now what we're going to do is we're going to continue in our interpretation to the cutoffs module. So when we look at the cutoffs here, there are a couple of options here. So we have it set up out of the box to calculate gross res, and net pay. And typically, if you look at how people have done this in the past, we assign uh, cutoffs based on various criteria here. And depending on, you know, the interpretation that you have, it may or may not be very sensitive to some of these cutoffs. So we're just going to do an analysis here on a couple of formations. And the ones that we're interested in for this exercise are the Parkman and the Niobrara. So for our Parkman here, this is a shore face to lower shore face sandstone. Um, it often has, behaves quite conventionally. It is a tight conventional system with some more unconventional aspects as we get down into the lower shore face part of the system. Uh, One thing we'll notice here is that the Parkman isn't very sensitive to clay volume cutoffs. So, but the way we would set the clay volume here is we'd come in and we'd say, all right, let's take our volume of wet clay, and let's say we want that to be less than or equal to, let's say 30% for this exercise. So we can come in and we can see now that updates here. So, what's now flagged is everything where we have less than 30% clay. We then can come in and set cutoffs on, let's say, our total porosity being, greater than or equal to, let's say, 8%. And we still want it to meet our criteria for gross reservoir. So we're going to add that in here, and we can see that, we've upped our porosity criteria, and now we can see that it's really the upper part of this that we're focused in on. And finally, we need to set our criteria for net pay. Now, the default here is around 60%, but really, we'll probably be able to flow hydrocarbons up to higher cutoffs here, so somewhere between 65 and 70%. We'll put that at 65%. Um, and we'll talk about how we might go about calibrating this in a minute. So once we've typed those in, we can zoom in here and we can see, that we have now got our flags for gross reservoir, and net pay. Now, what are some of the ways that we might go about calibrating how to put these cutoffs on? Well, a lot of times you'll hear people use back of the envelope type of numbers to get started, which is what I just did here. Oh, let's just set our clay volume at 30% and our total porosity at cut off at 8% and our saturation at 65%. So where do those come from? Well, what we would want to do is we would want to look at our core data. So let's say, for example, if we look at our relative permeability, and we think about that and we say, all right, what is the water saturation that corresponds to our relative permeability of oil essentially, going to zero? And what we'll see is that, the rel perm of oil to water, may occur at some value, between 65 and 70% in this case is what we're saying, and that's where we're setting that up. Another thing you could do is, let's say we're looking in a vertical well like this one. You could always go in and run a spinner survey and see where you're actually getting, inflow from the perfs. So where are we getting inflow of oil versus water here? Okay, that's another approach that we could take. Um, you could also look at productive wells versus dry holes and say, okay, where did we have wells that flowed 100% water? Where was what was our saturation criteria there? Where are wells where we haven't got any inflow in? Let's use that to help us calibrate our porosity or permeability cutoffs. So those would be a few ways that we could go about calibrating our cutoffs for gross res, net res, and net pay. Um, Now, one note on that is when you get to extremes, so if you're only interested in producing a couple of barrels per day, let's say, or your economics allow you to produce at very, very high water cuts, petrophysical cutoffs can be very difficult to set in those scenarios. So, I always like to say, petrophysics can help you identify where there is potential for hydrocarbon versus where there is not. And it can help you determine really good zones from, quite poor zones. But, if your criteria is that, flowing 1,000 barrels of fluid per day with only 2 barrels of oil is economic for you, these cutoffs may not make sense, and you may have to really rethink how you want to go about analyzing this type of system. So that is how we can set cutoffs and think about calibrating that. Now, I said we were interested in two zones here, both the Parkman and the Niobrara. So let's go down to our Niobrara here. All right, and the Niobrara, as you know, is an unconventional system, and maybe we want to use a different set of criteria here. So let's zoom in on just the Niobrara and think about how we want to set this. So I'm just going to copy and paste in the cutoffs so that way I don't have to retype them here. But then we can talk through how we want to go about doing this analysis. So, organic shell, like it's a marly limestone, we don't necessarily care that much about having ultra low clay volume, so we can probably be a little bit looser there. Maybe what we want to consider is actually using something like our mechanical rock properties to do that analysis, but we're going to use clay volume as a proxy for that for this exercise. So we're going to basically consider this whole interval to be gross reservoir with the cutoffs that we've used. Now, we are going to, of course, be horizontally drilling and fracking this reservoir. So using a high porosity cutoff is probably not appropriate. So we're going to use a lower total porosity cutoff. In this case, we're using 4%, and as we can see, almost the entire reservoir has porosity above that. Now, when we use our water saturation calculation here, we see that we cut out a fair amount of this. Now, we may also want to consider some more back of the envelope type calculations. Like, for example, maybe we say, whenever our resistivity is over 10 ohms, we want there to be net pay. So if we come here and we look at that and we look at our fill for this, maybe we say, all right, let's fill from 10 ohms to the edge to our resistivity curve here, and we would want all this to also be flagged as net pay over here. So how do we do that? Well, quite easily, we can come in and we can say, all right, let's use our saturation cutoff, or we can use a resistivity cutoff. And just to make it a bit more explicit, we'll wrap that in parentheses here. And now that will sorry, I meant to say resistivity greater than 10 ohms. Doesn't do any good if I don't put a cutoff there. And once we do that, now we see that wherever the saturation is either less than 65% or greater than 10 ohms, we are now flagging this as net pay. Now there's a few other options we have in here in Danomics. So first of all, we can require there to be a minimum thickness. So right now we're saying there's a 2-foot minimum thickness required. And then we have a few other options that we can use in here. One of these is mapping partial zones. So what happens if you're missing either the top or the bottom of a zone, or you have some null data in the middle? Do you still want it to be mapped up or not? And do we want to consider our data completeness? I think this is a very important parameter set here. I want to make sure that at least 75% of my interval is covered by gamma ray, resistivity, neutron, and density. So, we're only going to map up our summary results where we have at least 75% interval covered by these. Now, you can set that. You can also set what curves you would like to use in that determination as well. Okay, so that is how we calculate the net pay. Then the next step is, of course, taking that into the volumetrics. So when we look at the volumetrics, there are a few controls that we have here. So within Danomics, when we calculate volumetrics, we often report this on a per section basis. And so that is the area criteria that we have here. And then we also need to consider the other factors within our volumetrics equation. So, what's the, so we have porosity, we have saturation, and we have our formation volume factors. So how do we go about setting those? Well, with porosity, do we want to use a total or effective porosity? Most people in unconventional systems will say that, we can't really calculate an effective porosity, so we want to use a total porosity. And then there's the question of, do we want to calculate the volumetrics only where we have net pay, or do we want to calculate it where we have net reservoir or even gross reservoir? This is a bit of a philosophical decision. It's something that your company will probably have a standard for. In this case, we're going to calculate it on our net pay intervals because that's probably what's going to be contributing to most of our flow once we go in and frack this well. Then we want to consider, what do we want to do for our formation volume factor. Now, if you're in an area where your temperatures and your pressures and your depths aren't varying much, you can possibly get away with using one B factor over the entire area. But in this case, we're going to use our Vasquez and Beggs and Hall-Yarborough calculations to determine that. So what we need to do is we need to put in, let's say, a gas gravity and an oil gravity. And once we've done that, it will then calculate our formation volume factors for oil and gas for us and displays those here. So we can see we have a formation volume factor of oil of about 1.6 here in the Niobrara, and we have a formation volume factor for gas of about 0.004. And the results this is giving us, it would tell us we have about 23 million barrels of oil in place here. And, the associated gas with that would be around 20 BCF of gas. So, now we have this. Now, a couple of things that we could do is you probably have gas gravities from across the area, so we could bring this in either as a grid or as a spatial table to drive our analysis. Same thing for our oil gravity, from whoever your data vendor is, you would have access to, what the API gravity is in this area, and then we could use that as a parameter that gets mapped out across the area. And so now once we've done this, we'll have calculated our oil in place, our gas in place, our hydrocarbon pore volumes, our pH, and all that is available to map up here within Danomics. And then you could even take that back over into the decline curve analysis and use that to calculate your recovery factor based on your forecasted production. And we'll show you how to do that in one of our upcoming videos here on the decline curve analysis. All right, well, that is it for this video. We have uh, reviewed how to calculate our cutoffs and how we can go about customizing those, not just for calculated properties, but also for log properties such as our resistivity, and then how we can go through and apply those in the volumetrics, use correlations like Vasquez and Beggs and Hall-Yarborough to then calculate our formation volume factors given our pressure and temperatures, and calculate our oil and gas in places. All right, I hope that was useful to you. If you have any questions or you'd like to learn more, feel free to reach out and contact us at sales@danomics.com. Thank you.